Hi guys, Zoom class. Today we're looking at class test 2 and we're providing some worked solutions. Relax and enjoy the show. First question asked us to implement a 3x8 decoder for the following function. How do we do that? Well, the first thing to do is to put that function on a truth table. Now, the first term tells us that the function is a 1, listen carefully, wherever A and C are both 0. That's what that's telling us. So that's going to produce a 1 there and here. The second term tells us that wherever B and C are both 1, we are going to get the function as a 1. So that would happen here and here. The last one here says that A must be a 1, B must be a 1, and C specifically must be a 0. And that is this one here. So those are all the ones we're going to get on the function. And if it's not a 1, it has to be a 0. So we can safely go ahead and put 0 on all other rows. So we have a 3x8 decoder. So we have to draw our 3x8 decoder as a block. We're going to have 8 out. And these are going to be numbered 0, 1, 2, 3, 4, 5, 6, and 7. We are going to have a 3 in. And these are going to be numbered 0, 1, and 2. Now we have to apply our A, B, and C at that point there. And the A must go into the 2, most significant. The B into the 1, and the C must go into the 0. A lot of you made mistakes and not either labeling or correctly doing that part. Then finally, we have to connect the 1s to an OR gate. Make sure you put the F. You have to label everything. Now the 1s are on 0. 2 and 3. And 6 and 7. That's all that was required. And if you had everything there looking exactly like that, then you got 4 marks. Okay, let's go on to question 2. We're now supposed to use a multiplexer to implement that is the function there. So how do we do that? Well, we have to do the same thing. Basically, it's the same part at the beginning. We have to get that function onto a truth table. Now, the first term has A as a 0, B as a 0, and C as a 1. The next term has A as a 1 and B as a 0. Finally, the last term has A as a 0 and B and C as a 1. If it's not a 1, then it has to be a 0. So we are going to draw our 4x1 multiplexer as a block. A multiplexer has 2 select lines. Let me see if I can do that a little clearer. Right. A single output, which in this case has got to be labeled F. You can't just have wires hanging with no label. That's marks coming off, guys. Okay, so you have to get your A, B, and C into this. And of course, we have 0. Sorry, let's put 0, 1, 2, and 3. Don't forget to do that. Everything on the inside has to be labeled, and on the outside, it has to be labeled. Now, C is the least significant bit, so that is once again going into the 0 select line. Then we have B going into the 1. And now we have to have A going into the 4 of these. But how do we know how to do it? We draw another little table here that always is the same. You have no excuse for getting it wrong. We have on top I0, I1, I2, and I3, which correspond to our input 0 to 3. We have here A bar, and then we write 0, 1, 2, 3. And here we have A, and we write 4, 5, 6, and 7. That's automatically what you do all the time. So then what you have to do next is circle the ones that are a 1. So clearly we have a 1 on 1. Then we have a 1 on 3. Then we have a 1 on 4. Then we have a 1 on 5. Now, if the A is circled only, then we write A. If both the A and A bar are circled, we write 1. If none of them is circled, we write 0. And if the A bar is circled, we write A bar. So clearly the A is going to go into the 0, the A bar into the 1. Oops, let me just get that. And we can just write 1 and 0 here. And we're done. Okay? So let's go on now to the third question. The third question is to find the flip-flop input functions to actually use these input functions to find the state diagram, state equations, unused states, and if the unused states do not go back to the regular states or used states, then it is not self-correcting. Okay, so we start with the JA is B, JB is A or C bar, JC is 1, KA is 1, KB is 1, and KC is A B bar. So this table that we draw, it has A, B, and C in the present. It has the next state of A, B, and C. And it has the above inputs, JA, KA, JB, KB, JC, KC. So we do our usual binary from 0 to 7. And we proceed to fill in based on the above functions. JA is B. So I look at the B column and I write it down like this. KA is just 1. So all I have to do is write a 1 for all of them. JB is A or C. Well, A will give us the bottom 4. And C bar will be the opposite of whatever C is. So C is 0. So we have 1, 0, 1, 0. And KB is just 1. Now, JC is also just 1. KC now is A, B bar. Okay, so we have to look where A is a 1. and B is a 0. And that happens there and there. So we can write 2 1s there. Now, if it's not a 1, it has got to be a 0. So we may write so the next stage now is to look horizontally and see what we get. And I'm going to just write a little table up here to help you. 0, 0. Next equals present. 0, 1. Next equals 0. 1, 0. Next equals 1. And 1, 1. Next equals complement. Okay? Okay, so let's look at that table and look at what we have and just write it down. We see 0, 1 on KA, so we quickly write A as a 0. We see 1, 1 on JB and KB, and so we take this 0 here and we invert it, complement it to a 1. And we look here and we see 1, 0, so we immediately write a 1. So now you understand what we're doing, so we do it quickly. The next one is going to be 0, 0, 1 because that is what we see. The next one we have to look over here. Change that 0 into a 1. Change this 1 into a 0. And the last one is a 1. Finally, on the bottom row here of the first set, we have to change that 0 into a 1. Then we have 0, 1. Now, going along below now, below the bar, we have 0. We have to look at that 0 now and turn it into a 1. And look at this 0 and turn it into a 1 because of that and that. So coming on right away down, you got the picture now, so we just go without saying anything more. We have a 0, 1, 0. Hope you agree. Coming on down, we have 0, 0, 1. And the last one will be 0, 0, 1. Okay. Now let's take this marvelous table . Shrink it a little bit. Put it there so we can refer to it. We just need to put back the last 2 there. Now we can draw our diagram from here. And I'm going to use a different color so you can figure it out easily. Okay. We start here, which is a very good place to start at the beginning, 0, 0, 0. And we draw a little circle here. We write 0, 0, 0. And that goes to 3. And if you want to label it, you can say present goes to next. But now, guys, now what was the next is currently the present. So let's go down here now at 3. And where does it go? It goes to 5. And let's come down here at 5. And where does 5 go? It goes to 2. And where does 2 go? 2 goes back to 5. Right? So, what about the other 4? Well, let's go back up again since we've come to the end of the line and look at 1. 1 goes to 1. What else is not included there? We have no 4. What does 4 go to? 4 goes to 3. Four goes to 3 for the benefit of people who haven't yet got it. You must get it, okay? So what is missing from our diagram? 6. 6, guys. 6 is missing. Where does 6 go? 6 goes to 1. And 7 also goes to 1. Now, even though that is not the diagram I intended for the question, if you did the work correctly, that is what you should have gotten. So let us look at what else is required of you. Draw the state diagram. That is what we have just done. Find the state equations. How do we do that? Well, hopefully we can paste again, maybe, if we're lucky. Yes. Shrink. Now the state equations are found from the next state in terms of the present state. We shrunk a little bit there, but we're good to go. You don't have to make this a work of art, but you do have to make it work. Okay, so I've just drawn, quick as a bunny, they're very fast, you know. I've just drawn 3 Carnot maps correctly. I haven't put in anything yet, but I have drawn them. They're always drawn the same way if they are 3 variable Carnot maps. So now we are going to label A t plus 1, B t plus 1, and C t plus 1. And t plus 1 is the next state. Whatever state it is, t plus 1 is the next state. So let's come back up here and write next state. Right? Now, if we want to find the next state in terms of the present state, then we have to put the ones here into the squares from here. Get it? So in the first case, for the A, t plus 1, we have two ones. We have 2 and 3. 2 and 3. Where is 2 and 3 on the diagram? 2 and 3. All the rest have to be zeros. In terms of the BT plus 1 now, we have 3 ones. 3 ones, people, up there. Okay. So the first one is on 0. And then we have 4 and 5. And all the rest must be 0. Now, for the last one, things are missing again, unfortunately. We had 0, 0, 1 on the last state. For some reason, it keeps disappearing. I'm not quite sure why. But don't let that stop you. Let's keep going. We're on a mission right now. We're on a mission. Okay. So we have on the C1, we have a 1 on the 0, a 1 on the 1, the 2 and the 3. And we also have a 1 on the 4 and the 6 and 7. So there's only 1 0 right there in that little spot. So now we're done with that part of it. We have to circle, something that people are having a hard time doing still after all this time. Well, we have 2 1s here, so they don't have too much problem with that. Here we have 3, but the way they're organized, you probably will be able to do that. See that that is what it is, 2 circles. Now here, a lot of people go wrong because they don't realize the size of these circles. We have 4, 4, and 4. Right? What do those circles mean, people? What do they mean? They mean that everything inside of the circle has something common to it. So in what way do the 2 squares differ in the first diagram? Right? Both of them have A as a 0. And both of them have B as a 1. But they differ in C. We hope you can see that. If not, see it with the eye of faith. Okay? Now, what happens here with the next one? Maybe we need a little bit more room. Or we can just put the equals and put it down below. We have the first one here in the upright position has B and C as the same. They're both 0. And it has A and B bar. That is the horizontal one. Has A and B bar. Now, if you've reached this stage in my course and you still don't understand that, you really need to go further back, watch some other YouTube videos that deal with cardinal maps. But right now, we have 3 sets of 4 squares here. What is common to them? Well, clearly the first one is all the horizontal row where A is a 0. The one here on the right, the 4 there on the right, all have B as a 1. And the one on the corners, namely that one and that one, the edges, they all have C as a 0. So now you have found your state equations. There was 1 mark for finding each state equation. If that seems like a lot of work for 1 mark, well, you're not yet working fast enough, because it's very straightforward. And you've got to work faster. You've got to be more efficient in your time management and so forth and so on and all the rest of it. Now, what is the next step? The diagram asks, the question asks, what are the unused states? Unused states. Well, unfortunately, due to the misprint of my question, when looking at this diagram here, looking at this state diagram here, you have a hard time understanding what it even does, far less what are the unused states. So everybody, no matter what they wrote, got the 3 marks for that point, because as long as they drew this state diagram correctly, now that's what you had to do to make sure you get your 3 marks for the unused states. As long as you drew this diagram correctly, you would be forgiven for writing down any states as the unused states. Then the next question asks, is the device self-correcting? Well, clearly from your diagram, it is not. So in order to get that mark, you have to say not self-correcting. How do you know? Well, your diagram is discontinuous. It consists of 2 separate parts. It is, in fact, 2 separate diagrams. There is no connection between this one over here and this one over here. No connection whatsoever. So as a result of that unfortunate occurrence, it is not self-correcting. Okay? So let's go on to the next question that you have to do. Now the thing is, I'm doing all 6, 1, 2, 3, 4, 5. I'm doing all 6 questions. Remember, you, dear student, only had to do 4 of the 6. You had a choice. So what are we doing now? We have a sequence. 1, 4, 7, 3, 6. And it repeats. What does repeat mean? 6 goes back to 1, 4, 7, 3, 6, 1, 4, 7, 3, 6 until you switch off the power. That's what it means. Repeating sequence. We wish to build this with JK flip-flops. Well, you don't have to go to all that trouble. All you have to do is find the simplified flip-flop input functions. That's all you have to do. Analyze the unused state behavior and draw the state diagram. There are 3 things you are required to do. So the first thing you do is you have your present and your next and your flip-flop input functions. So the present is what? 1. Where does it go? To 4. Where does the 4 go? The 4 goes to 7. Where does the 7 go? The 7 goes to 3. Where does the 3 go? To 6. Where does the 6 go? It comes back to 1. That's it. Now, in order to know what inputs you have to put on the JA, KA, JB, KB, and JC, KC, in order to bring about that desired next state, you have to use the excitation table, which we talked about in the relevant lecture. So we have Q, and we have QT plus 1, and we have J and K. Now, what input do we have to put on the J and K to bring about a 0 on the next state? Well, it turns out that it is either 0, 0 or 0, 1. So we can write 0x. What input do we have to put on the J and K to bring about a 1 in the next state? For in this case, it is toggling anyway. So that would become 1x, which would mean 1, 0 or 1, 1. We really don't care. The X means we don't care. Okay? So here now we're going from a 1 to a 0. What do we need? Well, toggling is 1, 1, right? Toggling is 1, 1. And going to a 0 is 0, 1. So either we have 0, 1 or 1, 1. So we reverse the position of our X and our 1. And finally, we're going from 1 to a 1, which is either 0, 0 or 1, 0. So that will be X, 0. Which means we always have a 0 on the K, and it really doesn't care what we have on the J in order to bring about the desired behavior. Okay? So now we can look over here and we see we're going on the A from a 0 to a 1. We probably should label those A, B, C, A, B, C. Okay, so what are we doing? We're going from a 0 to a 1 on the A. That's that. So we have to write 1x. Then we're going from a 0 to a 0 on the B. And a 1 to a 0 on the C. Then we have 1 to 1. We have 0 to 1. And 0 to 1 again. Then we have 1 to 0. 1 to 0. Okay, no problem. 1 to 0. 1 to 1. X 0. 1 to 1. X 0. 0 to 1 is 1x. 1 to 1 is x 0. And 1 to 0 is x 1. And last, we have 1 to 0. We have 1 to 0. And we have 0 to 1. Now look at that, guys. Just take a moment to look at that beautiful sight and take it in. Better than Niagara Falls. Okay, so if you do that, you'll see that JA equals 1. Why? Because remember, the X is a very cooperative fella. He can be a 1 or a 0. He can be whatever we want. In fact, he doesn't care what he is at all. So we can make those x's 1, and that one will become all 1. So just in case you accuse me of not writing well, I want to make that perfectly plain that JA is 1. We also have a 1 here on JC. Then we only need to draw 4 Carnot maps. In order to do that, we've got to get this little diagram here quickly onto the next page. Right, copy. Shrink them down. And away we go. Let's just tidy it up a little bit there with that and that there, a little unnecessary. And we're good to go. Okay. So we have KA. We have JB. We have KB. And we have KC. So we've got to once again be drawing these quickly. We're not going to make a big thing out of it. It's not a work of art. If I take half the day to draw it, I will be setting you up for a fall in the exam. You want to just make sure it's got to be accurate enough that you don't confuse yourself, but it doesn't have to be a work of art. You're not receiving a lifetime award for a piece of art. All right, so there you go. Quick as a bunny. Time is running. Clock is running. Video is running. People are getting hungry. You want to get out of that exam room. All right, there you go. So now what do we do? What the France do we do? Well, we look up here at the KA and we put them onto the Carnot map here, the first Carnot map. Now, guys, please. If you put on the zeros and ones, everything else has to be an X. So you can do it that way quickly. That's a quick shortcut way of doing it. So what is it? The 0 here is at 4, isn't it? That's where the 0 is. The 0 is at 4. So let us make sure you use that column, the present column. And the 0 is at 4. So let me change the color so you can see. We put a 0 in 4. And we have a 1 on 7 by the same logic, and a 1 on 6, right? So this is 7, and that is 6. So we're gonna keep on it. We're gonna keep going. So let's look at JB now. We have a 0 on 1. We have a 1 on 4, right? Let's look at KB. We have 2 zeros, 7 and 3. And a 1 on 6. Then look at the next one here. We've got KC. We have that one, the last one we're dealing with there. We have a 0 on 7. And we have a 1 on 3 and a 1 on 1. 1 and a 3. Okay? So that's what I told you. Put on the zeros and ones, and everything else can be an X. That's a quick shortcut way. Get the zeros and ones in the right place. Remember, X's are only useful. I'm just trying to give you a speed tip. Remember, X's are only useful if they help you to combine it with ones, right? Ones is what it's all about. Ones is what it's all about. Okay, So look at those quickly here now and see what you see. Well, you can quickly see that this one here, those four, here, what can you do? Well, the first thing that pops out is that, and here you would have to do that, and there you would do that. So that would be the most obvious thing that you could do. But guys, listen up, pay attention. Something else is equally valid. Here you could have done that and that. You have to make a choice because there is only a single one. You cannot do both. I spoke about this at length in the lecture. So either your JB is going to be equal to A, or your JB is going to equal C bar. But you cannot have A or C bar. That is not right. You have to pick one or the other. Do I make myself abundantly clear? That is what I don't wish to be mistaken here. I want to make sure we are all on the same page. So here we have KA is equal to B. And here we have KB is equal to C bar. And here we have KC is equal to A bar. So what we're going to do now, we are going to draw two state diagrams so that we will be able to give students the solution, whatever they did. So let us come here now and copy these on to the next page. So whether you pick one or the other, you will still we only need it. That part is all we need. So we can rub out that. And what we're going to do is we're going to prepare now two tables to see what the next state is for the unused state. Okay. So let's do table 1 and table 2. We have A, B, and C. A, B, and C next. Present. Well, actually, we don't need that. We don't need that at all. That would be deceptive. We just do that, then that. What is the present A, B, and C? What's missing from our sequence? 0, 2, and 5 is missing. 0, 2, 5. There we go. Now, JA is a 1 all the time. That was what we discovered before. KA is always B. That is B. Pay attention. JB is either A or C bar. So let's do a JB for A and a JB for C bar. They're not identical. Matter of fact, they're opposites of one another. KB is C bar. I'm sorry, something here is not looking right. Yes, it is actually. Sorry, that's correct. Yeah. Okay. So KB is C bar. K. Sorry, JKB, KB, JB, KB, C bar. All right. So where do we have now? We have JC. That's where I made a mistake. Let's come back here. JC is 1, I believe. JC must be 1. Yes, JC is 1. Okay. JC is always 1. So we're good to go. KC is A bar. So we see that the students can only have a difference in the middle B. So let's see what happens. Applying the same thing you learned in the last thing, the 0 becomes a 1 there. That becomes a 0. That becomes a 1. That becomes a 1. 0, 1. And a 1, 1, 1. Down below, we have a 1, 1, 1. And we have a 1, 0, 1. And we have a 1, 0, 1. So in actuality, the people that chose the JB as a C bar, the JB as a C bar, whoops. Right? That's it. So let's go now to the next page. And let's say state diagram for JB equals A. State diagram for JB equals C bar. All right. So it would help to go back and get our original sequence. Shrink it down real small and draw the diagram for it. 1 goes to 4. 4 goes to 7. 7 goes to 3. 3 goes to 6. 6 goes back to 1. Right? One goes to 4, 4 goes to 7, 7 goes to 3, 3 goes to 6, and 6 goes back to 1. So we can, that's going to be the same. That has nothing to do with it. That's going to be the same for both. The issue is only what about the unused states. So let's see now. When JB is equal to A, we have 0 and 2 going to 5 and 5 going back to 7. Right? 0 and 2 going to 5. Sorry, 5 going back to 7. All right, there we go. Now for the next one, we have 0 going to 7. And then we have 2 going to 5 and 5 going to itself. So what does that tell you, people? That tells you that if you drew that diagram, you have so seeing as how you want a self-correcting device, you really have to use JB as an A if you are really building this animal. However, I didn't expect students to work all 2. So if they chose the C-bar and they got a non-self-correcting device, that was perfectly fine. You get full marks. I repeat, full marks. It is not your job to make the animal self-correcting. It is only your job to determine if it is or if it isn't. There's always a way to make the animal self-correcting, but that's not your responsibility. Okay, guys. So that is the successful conclusion of question 4. Moving right along, we come to question 5, which asks us to represent minus 215.65625 in the single precision floating point scheme. So first of all, we have to convert it. That's the first step. Convert it to binary. So we have 1, 1, 0, 1, 0, 1, 1, 1. Right? And it turns out that 0.65625 is 10101. Now remember, this is very simple. All you have to do is add up the ones. This one here is worth 128. That one is worth 64. That one is worth 16. That one is worth 4. That one's worth 2. And that one's worth 1. This one is worth 0.5. This one is worth here, 0.125. And this one here is worth 0. What? Well, 0.125 divided by 2, 0.0625, but that's that one, and that, so we need to divide it by 2 again. That's it. So now you just add those up and they come to what you have above. They come out to what you have above. I can't understand why anybody would have a problem with that. Please, guys, twig. You need to twig. And you need to twig quickly before Wednesday. Okay. So what we got now? We have to move the point. 1.101. Please copy it back right. Some of you add and remove. How many places did we move it? 1, 2, 3, 4, 5, 6, 7. Give yourself a pat on the back if you got that. All right. So what's next? Well, we take the 7, we add it to 127, and it comes to 134, and we convert that to binary by the same method you did above. We have 128 plus 4 is 132, plus 2 is 134. It's not rocket science, guys. It's quite easy to do, as quite a few of you got the whole thing perfectly right. Okay, so let's put it all together. First of all, we have a minus sign. That 1 is there for the minus sign. Then we write down that. One, not, 1, 1, not. Right? Then we write down this. So let's do a different color just to make sure that we don't have any confusion. So, congratulations if you got that done. Now you have to divide them up in groups of 4, starting from this side. Now we have a 1 here. What do we do? Add some more 1s, add some more 0s. In actual fact, we're supposed to have 32 bits. So we could add a whole heap more 0s. 4, 8, 16. Let me see here. We got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 4, 5, 6, 7, 8, 9, 10. I think that's right. Hopefully. All right. Don't stress, people. Don't stress. Do not stress. Whatever you do. What have you got? You got C. What have you got here? 3, huh? What have you got here? 5. What have you got here? 7. A. 8. 0, 0. Give yourself a round of applause if that's what you actually got. You're well on your way to your journey to success. Okay. So the last one now, and we're done, is to go the other direction. Okay, to go the other direction. We have 45, 82, E, 3, 0, 0. That's what we have. And we're supposed to find out what number, decimal, real number is this. Well, we first of all have to do the reverse direction. 4 is, that's 4. 5 is, that's it, that's 5. 8 is, that's 8. 2 is, that's 2. E is that. And 3 is that. Well, you can put 8 more zeros if you want, but it's probably not going to help you all that much. You just stick them in there for wise purpose. Wise purpose, people. Everything is wisdom and purpose. Now, what are we doing now? Well, we have to pick off this first bit, which tells us that the number is positive. Right? Positive number. Then we pick off 8 of them. 1, 2, 3, 4, 5, 6, 7, 8. What is that? When we convert that binary to, decimal, what do we have? 128 plus 8, which is what? 128, 136. Then we have 137, 138, and 139. So if you got 139, be thankful. Now, what do? You take away 127. Remember, we added it when we were going in the other direction. And that gives us 12. Right? So then we look here. Or let's, what color did I use before? Oops. What color did I use before? I used green. Yeah, let's go to green. Green is a nice color. All right, so let's go to green. Let's bring it down, people. Bring it down. What is it? Now you have to put a 1 in front of it. 1 point. Zero, 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 zero. 0, 1, 0, 1, 1, 1. 0, 0, 0, 1, 1. Right? Have I made anything? No, you've not. Be confident in yourself, people. You have to be confident in yourself in the exam. Don't doubt, because time is precious. So what do? You write here by 2 to the 12th. That's how you pass exams quickly and get things right. All right, so that's what we have to deal with, right? That is what we have to deal with. So all we need to do now is to move it 12 places over. 1, 2, 3, 4, 5. Or let's do it here for you. Let's just do it here for you. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Good. So what does that work out to? 1 followed by 5 zeros. Count them to make sure you get your right number. 1, 0, 1, 1, 1. 0, 0, or not, depending on what you like. 0, 1, 1. The last step now is to turn that into a number. Right? Turn that into a number, people. So you don't have a 0.5, but you have a 0.25 and a 0.125. That's what you have. So you go 0.25 plus 0.125 gives us 7375, doesn't it? So whatever number you get out, it's going to have a 0.375 after it. Right? What about the other way now? What about the other way? Well, we can go 1, 2, 4. Let's make a stop. 4, 8, 16. No 32s. 164. And then we have no 128s, no 256s, no 512, no 1024, no 2048. But we have 2048 multiplied by 2, 4096. Right? Add it up. 6 and 4 is 10. 6 and 4 is 10. So that comes out to 28. 6 and 1 is 7 and 2 is 9. Twice 9 is 18. So that comes out to 4,188. People, that's your lucky number. If you got that, you're among the guys that probably got a 4 for the question. The number is plus 4,188.375. Thank you so much for watching the Stephen Mendes channel, and do have a wonderful Christmas. See you in the next video.